The marine environment now contains a vast quantity of tiny pieces of plastic smaller than 5 millimeters in diameter. Called microplastics, much of this material is microscopic in size. Microplastics are so small that we hardly recognize them as litter, but they are everywhere. As large pieces of plastic litter break down into ever smaller particles, they become microplastics.
If you picture it in terms of every handful of sand that we've examined, we've found plastics in every handful of material that we've looked at. So it shows quite clearly that plastic debris, even at the microscopic scale, is now present worldwide in marine sediments, certainly in shallow waters.
Because the severity of the problem is only now being fully appreciated, there have been few scientific studies of microplastic pollution. Thus, we don't have a good understanding of the amount of microplastics already present in seawater, sediments, and marine organisms. Nor do we fully understand the distribution of microplastics across the globe or their impacts on marine life. Already, however, there are alarming examples of the distribution and ecological impact of plastics. There are pools of plastic garbage as large as the continent of Europe in the oceans, for example, and marine animals across the globe mistake plastic for food, often with fatal consequences. Just as bigger animals eat large pieces of plastic, tiny creatures at the base of the food chain eat microplastics. Large or small, animals that consume plastic are at risk of starvation because the material has no nutritional value. In some cases, plastics never leave the stomach. There is another potentially more serious process at work. As small animals at the base of the food chain ingest microplastics, the toxic chemicals contained in plastic enter the food chain. These chemicals interact with numerous biological processes and may eventually pose risks for humans eating contaminated marine organisms. Long-term hazards of these chemicals for humans include cancer, changes in genetic material, and adverse effects on reproduction. Because the particles are so small and are already so widespread throughout the marine environment, cleaning up microplastics seems impossible. Disturbingly, the amount of new microplastics entering the oceans appears greater than the amount we could clean up over the same time period. Reducing the amount of plastic litter entering the marine environment is the best strategy we can employ for coping with the problem.